Hello everybody, and today we're going to learn about absolute value inequalities. To solve an absolute value inequality, it's very similar to solving the absolute value equations that we've been practicing in class. So let's look at our first example to see how to solve these. The first thing you need to do, just like we did with our equations, is to make sure the absolute value is all by itself. And in our first equation, the absolute value of 2x plus 3 is less than 7 is all by itself. So we can go ahead and set up our two equations. So again, to set up our two equations, you take the stuff inside the absolute value, 2x plus 3, and make it less than 7. The second equation is to take the stuff inside the absolute value, and notice the absolute value is no longer in our equations, but this time you change your inequality, so now I'm going to change it to a greater than, and you change the number, so now it becomes a negative 7. And now you can solve. So when I solve the first equation, I subtract the 3, and I get 2x is less than 4, divide by 2, and x is less than 2. When I go to graph that, I have an open circle at 2, and I can shade to the left. My second equation, I subtract the 3. I'm left with 2x is greater than negative 10, and now I divide by a positive 2. When you divide by a positive number, there's no need to change your inequality sign. So it's still going to stay x is greater than, and now it becomes negative 5. When I go to graph that, I have an open circle at negative 5 and shade to the right. Notice my shading is going to collide. So my answer are all of the numbers in between negative 5 and 2, but not including those numbers. So if I use interval notation, it will look like an open bracket, negative 5, comma, 2, open bracket. This shows my solution exists between those two numbers, but it cannot be those two numbers. Let's look at the next example and do that one together as well. The next example is the absolute value of m divided by 3 plus 2 is less than or equal to 2. Now my absolute value is by itself, so I can go ahead and set up my two equations. M divided by 3 plus 2 is less than or equal to 2. My second equation is again the stuff inside the absolute value, m divided by 3 plus 2, but this time you change your inequality to greater than or equal to, and you change that 2 to a negative 2. Now we can solve. Subtract the 2, m divided by 3 is less than or equal to 0. To get rid of the denominator here, we'll multiply by the reciprocal, 3 over 1. To both sides, and get m is less than or equal to 0 times any number is 0. So there's my first equation. Put a closed circle at the 0, and we can shade to the left. The second equation, subtract the 2. M divided by 3 is greater than or equal to negative 4. Again, multiply by the reciprocal, 3 over 1, and you're left with m is greater than or equal to negative 4 times 3 is negative 12. Since negative 12 is not on our number line, we can go ahead and just add those numbers, negative 11, negative 12. Negative 12 has a closed circle, and we'll shade to the right. Again, our solutions collide. So our solutions are all of the numbers in between negative 12 and 0. To show that with interval notation, closed bracket, negative 12, comma 0, closed bracket. Let's look at the next page for two more examples. Example number 3 also has an absolute value that's all by itself. So we can go ahead and set up our two equations. Again, set the inside of the absolute value, 2 plus 3a, greater than or equal to 4. My second equation, 2 plus 3a, notice no longer do I have absolute values, Change the inequality to less than or equal to, and -4. Now solve. Subtract the 2. 3a is greater than or equal to 2. Divide by 3. A is greater than or equal to 2/3. Now 2/3 is not on my number line, but you can add that number. So 2/3 is going to be between 0 and 1. So just put a line there showing that that's where 2/3 would be. And this would be a closed circle. Now for our second equation, subtract the 2. 3a is less than or equal to -6. Divide by 3. And a is less than or equal to -2. Now find -2. And that also would be a closed circle. Now we didn't shade yet, so for our first equation, my first closed circle in blue, my 2/3, since it was greater than, I would shade to the right. And for my red answer, which was number 2, that was a less than, that gets shaded to the left. So now my solutions are going the opposite directions. To show this with interval notation, I would have -∞, comma, -2. Remember, the infinity gets a soft bracket, but the -2 would get a hard bracket because it's a closed circle. To show that I want to jump to my next equation, remember that's going to put a u in between. And now I start out at 2/3. Since I included, it's a hard bracket, comma, to infinity, soft bracket. So there shows my two solutions. Let's look down and do example number 4 together. Example number 4 is the absolute value of x divided by 5 is greater than or equal to 1.2. Since the absolute value is alone, we can go ahead and set up our two equations. X divided by 5 is greater than or equal to 1.2. And x divided by 5, switch my sign, less than or equal to -1.2. Now the only thing we need to do is get rid of that denominator 5. So we multiply by the reciprocal, 5 over 1, and get x is greater than or equal to, comes out to be 6. So 6 on the number line has a closed circle, and all the numbers that are greater than are going to go to the right. Now for my second equation, again, multiply by the reciprocal, 5 over 1. And this time I get x is less than or equal to -6. So -6, closed circle, the numbers that are less than that are going to go to the left. So again, I see I have two solutions, but they're going in opposite directions. To show this in interval notation, open bracket, -∞, comma, -6, hard bracket. A jump is the u. Go to 6, hard bracket, comma, infinity, closed bracket, with a soft bracket for my infinity. I'm going to end the video here. I would like you to try examples 5 and 6 and come into class with those two done. See you tomorrow.